Hi everybody, my name is Lawrence Mirabal. I'm currently working down here in Dallas, Texas for Encore Power Transmission. Today we're going to be going over the weather monitoring system and smart home automation project. So the purpose behind their project was to simplify people's lives by analyzing the weather for a given location. It's from a central point, allowing tasks to be done automatically, and that central point is actually being operated by using the output of a weather monitoring system. The system also has other sensors put into place in order to keep the house safer for all the residents within it. Today we're going to be going over a small overview of home automation itself and what it is, the hardware that was used, how the software platform plays a critical role behind everything, the methodology behind the project, its possible outcomes, and then we're going to sum it up with the conclusions from the paper. So, what is home automation? So, home automation allows for the control of home devices from one central hub. This can be either used by devices or other things such as voice commands. So this project pertains to home automation of monitoring the weather for the house of a specific location, making it easier, also safer place to live in general just by sensing gas leaks or smoke. And it has also added security with a password door that can be operated if the password is entered correctly. Another feature is that it also captures photos of the user and mails it to the admin using that software platform that we're going to talk about here shortly. That's that goes with the security part of it. This way that all of it's all centralized and it's easy to be distributed out to the users that are needing it. So this makes it easier for the residents of the household as they have less to worry about when it comes to security purposes. It also allows for weather updates, which will allow the residents to expect a certain weather for the day, which is critical because now that it's starting to get cold, you don't want to walk outside in shorts and a t-shirt, even though it's winter time and you kind of expect it to be cold. So the system can be automatic, but it also can be manually controlled, allowing for a lot more flexibility for those who are, let's say, not so tech savvy. Overall, it allows for significant savings since things can be controlled remotely or automatically. Say your AC system needs to be set to a certain temperature inside when you want to be home. But when it reaches the temperature you want it to before you get back, then it can actually shut itself off. So the hardware components we're going to go over today, we're going to go over the Arduino board first. So this is actually a microcontroller based on the ATmega 328P. Consists of 14 digital input and output pins and a 5-volt regulator with a 16 megahertz oscillator. So the first actual sensor we're going to be going over is the DHT11, which is a composite sensor that calibrates a calibrated digital signal output of the temperature and humidity. So it contains, basically it reads the temperature and the humidity outside, and it's going to be able to display it. So it doesn't display it itself, but it uploads that information like through the 5-volt input to our Arduino, which is then programmed. And we'll get into the programming here shortly. So that DHT11 contains a resistance sense of wet components and is linked with a high-performance 8-bit microcontroller as well. Next component is we're going to have an LDR or a light-dependent resistor whose resistivity is a function of the incident electromagnetism radiation. These are light-sensitive devices. They're also known as photoconductors or photocells. They're made up of semiconductor materials that have a high resistance, and the basics of this work off of the principle of photoconductivity. I recommend kind of looking into it. I just didn't want to have time to kind of go and dive into it today. So next is the atmospheric pressure sensor, which is the BMP 180, which is a high-precision pressure sensor that uses for many applications, including commercial use. These work on piezo-resistive technology, which allows for linearity and high accuracy as well as long-term stability, which is critical when it comes to a gas sensor or a pressure sensor, because you don't want it to wear out over time. You want it to be able to last, and it also just be stable so that it's not giving you misreadings. Next, we also have a gas sensor, which is used to detect the gas in that area as well. This project used an LPG, which was used to detect carbon dioxide, methane, and LPG gas concentrates in the air. It's also sensitive to propane and butane mixtures, but it can also detect concentrations between 200 and 10,000 ppm, which is parts per million. The last hardware component is the HC05 Bluetooth module, which is a serial port protocol module designed for wireless serial connection setup. This uses the CSR Bluecore 04 external chip system with CMOS technology and has an adaptive frequency hopping. So now we're going to kind of dive into our software platform here, and so the basics of their software platform is all using MATLAB, which is really easy software to use, and it pairs really well with our Arduinos. So the basics of the password matching door lock system are controlled by the MATLAB GUI. MATLAB is also interfaced with the Arduino microcontroller by the password input from that controller and allows it to switch to a totally automated design. So password matching is when we take the input of letters, numbers, or characters and compare it to a pre-declared string. And then if the strings match, the controls and Arduino interface will actually open the door. But if the password's entered incorrectly, it's going to snap an image of the whoever was trying to put in the password and mail it automatically to the admin of the system. So in this prototype, the image capturing is done through MATLAB coding using the inbuilt laptop camera. The camera snaps a picture in a matter of seconds, so it has a slight time set to it, and then it's going to end up taking that picture for just after that timer is finished up, and then it's going to email that out. So the coding syntax for the email system takes the sender's email address and password as well as the receiver's email address, runs the code to make sure that the captured email is automatically emailed straight to the admin instead of having to be redirected. So the mailing website that they want you to have open in order to receive these notifications was their SMTP setting for the recipient. So the Arduino interfacing is done by coding and controlling devices through the microcontroller using MATLAB. The hardware packages that they downloaded for the Arduino was the MATLAB software. So the syntax used for the voice recording portion is executed to take that voice input signal. The signal of the input is then plotted using the software, and then the disturbances in the signal of the background noise can be eliminated by using a filter. So in order to do some of the input voice and only recorded noise that are plotted and calculated using the Fourier transform method and then subtracted from one another. So now we're going to kind of dive into the methodology behind the project. This is going to kind of go over everything that they were trying to use it for and a little bit of the reasoning behind it. So the main reason for this project is to design the weather station and the home automation system. So the weather station is constructed mainly using sensors to sense the surrounding conditions. It takes data from weather stations to control the household appliances to create comfortable surroundings in your household. Makes it a lot easier if you're coming home and you want it to be like right now, it's cold out. I'd rather have it be nice and toasty when I get home. So on the left here, we're going to have our basic block diagram. They're just kind of showing you a general idea of what they want it to be able to control, how it's all going to feed in, and what it's going to send out to our Arduino. So the sensors are connected to the ports of the microcontroller, which are easily accessed and monitored by the Arduino. Now the monitor readings are given as an output in different types of sensors and modules in real time. The Arduino microcontroller embedded within the board comprises of an analog to digital converter, which converts the analog input signal to a pin between 0 and 1023. The integer number is proportional to the amount of voltage being applied to the analog input. Any sensor operating on 5 volts can be directly connected to the Arduino board, and this prototype uses a simple setup. So the Arduino has trigger options, which also switches that actuator on and off, but it can also regulate the voltage or output from the ports of the microcontroller. So here on the right side, we're going to have our final block diagram. It goes a little more in depth about what they were trying to do with the microcontroller and how it feeds into the next thing, which is, and then it shows how that controls whatever it's set for. Let's say the DHT11 sensor. It's trying to go from your AC on and then to your heater on or your PC fan on. It's basically just kind of controlling the other devices, but that's the general of their final block diagram. So now what we have here is we're going to kind of continue on, but we're going to go over the smart temperature and humidity sensing, and then the LPG, which is your smoke detecting. So in this project, the temperature and humidity parameters are determined by the DHT11 sensor. It's a low-cost digital temperature and humidity sensor that ranges from probably around $5 to $10 on the research I did on Amazon and other websites like that. So it uses a capacitive sensor for the humidity and a thermistor to measure the surrounding temperature. And then that output is taken to a digital signal on the data pin, and then that data pin is received by the Arduino. The temperature and humidity is then viewed on the computer screen or the LCD display. So this prototype uses this MTH or DTH11, to determine humidity in the microcontroller to regulate a fan or a switch if the humidity increases. If the temperature increases, the controller is switched on, and then the air indicator, the AC indicator that they are using is a LED just to show that the system is going to work. Usually you'll have it set up straight and run off to your AC system to turn it on. So for the LPG or the smoke detection on the MQ2 sensor, the main advantage of this sensor is that it's very sensitive to smoke, but also flammable to gas. So it accounts the output and voltage level, which means the more smoke, the greater value of the voltage in the output. The build and the potentiometer of the sensor can be adjusted in a way to calibrate the sensitivity. It is also connected to the Arduino sensor in a way that it can read voltage output and trigger an alarm showing a message, let's say house on fire, or high propane alarm or something like that. That way the user on the admin side is able to see kind of what's going on in their household. So now we're going to kind of continue on, but we're going to go into the smart home security that they implemented, as well as their voice recognition. So the home security system was configured using the MATLAB software and then its GUI platform. Comprises a portable panel which has a bunch of push buttons on it that have different commands, a camera, and a connection to a LCD display. If the password entered matches the string, then the MATLAB interface sends a message to the Arduino board using the USB cable. Then that door will open and the automation system will then be turned on. If the password is guessed incorrectly, the camera's trigger snaps a picture of the person trying to open the system and sends it straight in an email to the admin of the system. So for the voice recognition, a smart feature that was implemented is that it's kind of more based off of for let's say blind or disabled users. I guess also some elderly users that kind of understand how home automation works. So the user can give voice commands and turn on the control the brightness of lights, regulate fans, etc. The program will also identify the specific voice command, and then thereby it'll transfer a message to the Arduino Uno system. So that Arduino will then turn on and off the LEDs and fan motors and regulate them in the order of the messages being received. So some possible outcomes that we have here is that they wanted to provide efficient home automation. This way it was a lot simpler for users to actually come out and use their system, but also make it just so people that have an easier control of their household instead of having to come home and have to turn everything on manually. It's just a lot easier to get it done from a distance. You just push a button or something and your lights will be on when you walk in the door, your heater's on, it's not cold inside. Currently, they're still building a prototype, as you see on the right side. You got your fan and all your sensors over there, and they have an LED as well for the AC system. So their core actions, they kind of just have it based off of being able to determine the temperature outside, the humidity, the pressure, and then they implemented the home security and the voice recognition to kind of make it more attractive to a different user instead of just being like a temperature and humidity sensor, because they want it to be usable for multiple ways instead of trying to stick to just one idea. And then the best thing I like about it is that they are still aiming for helping people with disabilities, because it makes them allowed to have a greater audience for the project rather than just being stuck of, well, this is our specific audience here and we're not really going to target anybody else. But they're really helping other people that are not, able to go out and try to use this system that, or can't see or that can't actually get up and use it. So the conclusion, so basically it's a low-cost system. It's very effective. It's designed to improve your home living standards, but it can also be a lot more advanced. So the idea of controlling home appliances and providing security for the system using MATLAB software is very, very beneficial. The cost is low and can be afforded by any common person. It's a really cheap system to build. I think our kit was, $35 to buy. You already have a lot of sensors in there. You can get the other one for $5 or $10. It's really cheap and cost effective. So it's also designed to improve the standard of living. Oh, sorry. My apologies. So The voice control function provides help and assistance, especially to disabled or elderly people. Security system provides a safeguard for possible intruders, or possible intruders coming into your house. You don't want them to just access your house right away. This makes sure that you even have a photo image of them for trying to access it. Makes it really easy to track down whoever's trying to get in your house. The future scope of this project can be more advanced by implementing motion sensors that switch lights or fans, and I think that's really critical now because of how much smart home automation we have. Like, I know if I walk into a room and I have a sensor set up, it'll automatically turn on my lights. Now, I think this one can be used to minimize the time delay that it takes for that light to actually trigger, because I know when I walk into a lot of commercial buildings or even an office or somewhere that have automated lights, there is a delay, so you're still kind of taking a few steps before that light will turn on. So overall, it's a simple design, but I really do think it shows a lot of potential, and I could see it being used in the future. So thank you guys. Appreciate you guys being here, and I hope you guys have a good rest of your semester.